Chapter 1, Lesson 1. We're going to create an objective of what we want to learn today, and we're going to learn some basic terminology. So basic geometric terminology. Okay? So that's the whole gist of our conversation today, is to talk about some stuff and introduce you to the fine world of drawing on paper. Okay? Now, some people like to use rulers when they're drawing to make their drawings as specific as possible. Some people just kind of ad-lib, but you got to be reasonable in your ad-libbing. All right, so I'm just going to give you some terms. First term I want to give you, we'll go back to basics here, and that would be the term equidistant. When I underline a word, that tells you it's a vocab word, and you're going to make a vocab card. They're going to be on 3x5 index cards. You don't want them cut in half. You don't want them larger than that because they get cumbersome. You want to put the word on one side and the definition on the other. That way you can actually test yourself to see if you know what they mean. Now, a lot of things that we've learned way back in the old days when you were first learning about big words, they turned out to be a lot of times compound words, where you took two separate words, put them together, and made a new word. And this is somewhat of a compound word. Equa stands for equal, and distant stands for distance. So if you had to venture a guess on what this word means, you would say equal distance. So we're going to say, and we're going to add a little bit to that, points, because we are in geometry, that are equally distant from a third point. So, for example, if you're a city planner and you wanted to have the flagpole in the center of town be equidistant from the park and the courthouse, where would that flagpole have to be exactly? And so you could use this notion of equidistance to help you do that. Okay? And they have a really nice example. And again, every time that you are doing a lesson, you should be reading the book. And I'm going to go back and add one thing here up at the top. This actually comes out of, oh, go away, bugger. Sorry, I have to write backwards. Lesson, chapter 1, lesson 1, and also lesson from chapter 1, the second. So you're going to read the first and second chapters, or the lessons in chapter 1, help you as you get ready to do your homework. So just read through those. It's kind of good information. Always get in that habit. All right, so what is a word that I used in that definition that is a geometric term that we need to identify? Dakota. Point. The word points. So that's what we're going to be working on now, is the word point. So we'll just say point. And here's the first part of geometry is really weird. It's not a thing. It's a direction. All a point is a location in space. Okay. It doesn't have any dimensions. So it's not long, it's not wide, it's not high, it's none of those things. And when we write about a point, it's represented by a capital letter. We tend not to see a point. Let's say you graph something. So you can just do something like this. Oops. Here's your x-axis, here's your y-axis, and there's this. We would call that, read it as point A. You can see it also written this way. That means the same thing. If you just see A, in geometry class, we're going to take that to mean a point. Okay? All right. What's something that if I put a whole bunch of points together, what would I create? Colleen? I would create a line. All right, so we're going to, everybody done here? Can I move to the next page? Are we still writing? Let me know. We good? Yeah. Okay. So our next definition is going to be the word line. So remember, this is our third vocab card you're making at this point. So a line is a collection of points that extend indefinitely. That means forever and ever. In opposite directions. It has one dimension. What do you think its dimension is? It's one dimension. What dimension? Length. It has a length. The reason why it's not two-dimensional, and I totally get where you're coming from, Isabel, you think it should be two dimensions because it's got a length, infinite number going in both directions, and it should have a width, right? It's the width of a point. But does a point have width? No, it has no dimension. That's the freaky bit, okay? So it just has a length. I know, you just have to accept some things, okay? We'll talk about that. It's named by 2 points on the line, topped with a symbol of a line, or a single lowercase italic letter. Does anyone not understand the term italic? Not metallic as in Metallica, just italic. It's kind of cursive. Okay, you'll see it in your book. Now, so if I have here, I'm doing a different color, and I just arbitrarily take 2 points on that line, and we'll call it 1 point A and 1 point B. If I want to name that line, my two options, option 1, is to write the 2 points and then put a symbol of a line on the top. We call that, in words, line AB. Would I be talking about a different line if I talked about line BA? No. So it's kind of order doesn't matter. What mathematical property is that? Commutative property. So the letters are commutative when it comes to the naming. Now, if I wanted to name it with just one letter, I could use an italic L. That also represents a line, the same line. And we would say line L. That's how we would read that. So those are the options how you would name a line, okay? All right. What if I have 2 lines in the same area? What have I now just created? Dakota? Not necessarily. Allie, do you have an answer? Okay. Rachel E? Not necessarily. I'll give you a hint. Look up. Look down. Look left. Look right. Look front. Look back. What would we call those things that you just looked at? And don't say ceiling, floor, walls, okay? Knock in. Those are planes. Okay, so that's our next word. Everybody ready? Can I move? So our next vocab is a plane. Plane to plane. And we just call it a collection of points. So it could be just a whole bunch of points. It could be points contained in lines, okay? That creates a flat surface, and I'm going to put that in quotation. Now here comes the key part. That's right, extending indefinitely. Now, while I can say this is a plane, what does it look like to you in other words? Okay, it's a plane, but what does the shape look like? A rectangle. What is a rectangle infinite, or does a rectangle have an edge, an edge, an edge, an edge? Okay. So here's the problem: is that in order for us to draw planes, we actually have to draw a rectangle or a parallelogram, because we have to have a starting and ending point. Otherwise, we could never draw it. So while this plane continues forever in all directions, for our purposes, we can only deal with the piece that we can see, okay? So that's the hard part, is thinking about these planes. You know, that wall there extends into the ground, extends into the heavens, extends across the horizon. It goes on and on and on. But we couldn't draw that, right? We don't have paper big enough, and that's the only thing we do for the rest of our life and never achieve our goal of having drawn it, okay? Now, because it is this somewhat flat surface, it now has two dimensions. It has the length like a line, but it also has a width. There are no edges. Even though we draw it as if it has edges, we're just doing that so we can actually talk about it with other people. Now, strange thing, it's named somewhat similarly as a point. So it's named by a capital letter. So the problem is, how do I know whether I'm talking about a plane or a point? You have to look at the context, and that will determine it. So how we tend to draw planes is a parallelogram. So it's trying to give you this dimensionality. You'll see a letter, a capital letter, which, by the way, represents what on that plane? It represents 1 point out of an infinite number of points. And we would read that as plane M. So M could mean a point, M could mean a plane. How you know which one's which is by looking at the context of the situation. Okay, if I took all the points that existed and looked at them as one big whole, what am I now talking about? What's out there? Isabel? Yeah, but we have a name for the collection of all points that exist. Not okay. It is space, exactly. Space is the set of all points. Now, here's this. Can I be honest with you? That weird noise you heard was me trying to do the Star Trek theme, but my throat isn't working today. So I apologize. I'm going to have to bring in little video clips and so you don't have to listen to me. Okay. Couple more vocab words. Some more hideous drawings. Hopefully no more scary noises. If we have points that form a line, they're called collinear. Co, as in together, linear, as in a line. So there are points all in one line. Naming just 3 points on that line, A, B, and C, we would say A, B, and C are collinear because they're all on the same line. They're together. And then the opposite of being collinear is to not be collinear, and we call that non-collinear points. And those are points that are not all contained in one line. You may have some of them in a line. You may be able to form a line through some of them, but you won't be able to get all of them on one, on one line. Okay, so those points would be considered non-collinear because they do not form one line. I could form a line through AD, I could form a line through AC, through AB, through BD, BC, and so on and so forth, but I cannot get one that contains A, B, C, and D. And just like we can talk about lines, we can talk about planes. Have the same idea. So we have coplanar points. And notice spelling is really important. I get really irritated when I have to look at words that are misspelled. Coplanar, not coplanar, coplanar. Coplanar points are points all in one plane. So there's your plane. And all those points are in that plane. And then his cousin, that he doesn't get along with, are non-coplanar points. And those are points that are not contained in one plane. Okay, here comes the fun part. Are you ready to learn how to draw something really freaky? It's kind of like, looks like a Band-Aid to begin with. So kind of a parallelogram that is going sideways. And then cutting through it is another parallelogram. And then I have to do a little repair work. Okay. Now, coplanar points would be these blue guys, because they're all on that plane that goes across. And then we have some other points going the other direction. But the blue and green would be considered non-coplanar because they're not all in one plane. Okay? And then I've got one more term, and that's called an intersection. Remember what I told you? Beginning chapters of new stuff, lots of vocab. And intersection is just the set of points that two figures have in common. So here's the question to ponder. We studied about something last year in which there was one point of intersection. What was it that we studied where you ended up getting 1 point of intersection? 1 point that these two figures had in common. Okay. Isabel, you got it, remember? Not parabolas. That's not all, because usually there's an x-intercept and a y-intercept. And sometimes with parabolas, we had two intercepts, right? Okay. Do you guys remember studying system of equations, where we had two lines, and the whole point to the system is to figure out what they had in common? It was one ordered pair. Okay? So here's the thing to ponder that I'm not going to share with you today. I'm going to see what you can share with me tomorrow, so you might want to write this down. What is the intersection of two planes? What would be the intersection of two planes? Okay? Now, I'm going to give you your homework verbally, so you're going to want to write this down. I'll get up on School Loop. It's not there now. Tonight's homework is page 7 through 9. Questions 1 through 10, 11 through 27 odd, and 28 through 30.